fundamentals. When you look at the exam topics for the new CCNA, you'll notice that this particular topic feels a little out of place. Cisco is asking us to explain the fundamentals of virtualization, specifically as it pertains to virtual machines. Now, this isn't necessarily talking about network device virtualization and virtual machines in that respect, but just virtual machines in general, more specifically virtual machines hosted on more generic hardware, which network devices can be virtualized on, and we'll talk a little about that a bit later here. But first, let's go ahead and talk about what a virtual machine really is and how it differs from our traditional architecture. So, traditionally, you have these single physical machines running a single operating system. Generally, these are single purpose, is that if you have your domain controller with your DNS services and maybe your DHCP, maybe if you might split that out as well, but you're going to have that running on a single machine. So in the traditional architecture, you would have a single physical box that would perform those services. This ends up giving you a lot of sprawl. In larger organizations, when you need many domain controllers and many DHCP servers, and you have separate machines for many different applications that your organization is running, and you can only ever have one application on each machine because you want to separate them out to limit the amount of conflict that they end up having with each other on the operating system, that you end up with rows and rows of physical machines, that every time you need to spin up a new machine, you need to physically send someone out there to rack and stack a new physical device, to set up a new operating system, and to get that going. This also ends up meaning that the physical machines are often underutilized, that when you only have a single purpose on your physical device, you might peak out your CPU at 10%, and that's it, and maybe 30 when it's running updates, but you end up really underutilizing your machines, and that does not look very good for your efficiency of your business or for the IT department. Now, in physical machines, of course, the OS has direct access to the machine hardware. The operating system is directly interacting with the processor and with the components on the motherboard. It is interacting with your memory, and the operating system is handling its own scheduling for that hardware. And as far as the operating system is concerned, it has full access to the hardware available on that physical machine, to that physical hardware. Like I said, this does limit machines to a single purpose because it limits the physical machine to a single purpose, because you can only have one operating system running concurrently on your machine. And that caused significant server sprawl with regards to the physical devices. Now, step onto the stage, virtualization. So with virtualization, you end up still having a single operating system that runs on your hardware, but this operating system acts as a hypervisor. Now, what does a hypervisor do? So a hypervisor will go ahead and present virtual hardware to a guest operating system. Now, the operating system that's running on our hypervisor, say each one of these little boxes here, right? That each one of these is a Windows Server operating system, just to give an example. Say you've got, Server 2016 running on each of these. And boom, here, and here. And that Server 2016, as far as it is concerned, it's here at the OS layer. It thinks that it has this physical hardware available to it, and it goes ahead and schedules its memory, it handles its processor tasks and schedules the processor, and does all of the operating system tasks as it normally would. But what it is interacting with is actually this virtualized hardware, this virtual machine that the hypervisor is presenting to it. So the hypervisor actually handles the scheduling and the resource management for the physical hardware, and takes the instructions from the virtual machines and schedules that out so that the physical hardware is able to react appropriately. Now, this does allow for some pretty interesting things, right? Is that, for one, you can over-allocate these guys. You can make it so that these machines think that they're huge. The sum of the parts can be larger than the whole. But that does cause some problems, of course. Say that you end up only having, let's say this machine, this physical machine has, 32 gigabytes of memory, right? And each of these 6 guys, you end up giving each of them 16 gigabytes of memory, right? Because whatever application that you're running on these guest operating systems, throws an error saying you don't have enough memory when you have less than 16. So you go ahead and give each one 16, and that works, and that's fine. But you can run into problems where if they start as a whole taking up more than the physical 32 gigabytes of memory, well, you've run out of memory, and you're trying to address space that's outside of your addressing range, and you could crash your hypervisor, crash your guest operating systems, or you could just suffer significant performance problems, depending on how your hypervisor is configured. So like I said, the hypervisor presents the guest operating systems with virtualized hardware, with virtualized machines. As far as this guest operating system is concerned, it has full physical machine available to it. It has a certain amount of memory. It has a video card. It has a processor with X amount of cores that's capable of certain instruction sets. That all of this is passed into the guest operating system, and the guest operating system is unaware generally that it is in a virtual machine, that it is on a hypervisor. So it just acts as it normally would, and the hypervisor handles those instructions appropriately so that it can schedule it out so that it all works in unison. Now, this does significantly increase our utilization, right? Is that now you went from this physical hardware that can only run one single workload in our traditional architecture. You have your application running on your one operating system that is running on your one physical machine. And then boom, now we have our one physical machine that can run many operating systems that are all individual computing areas, right? These are all separated from each other at the hypervisor, that these act as totally separate physical machines. They cannot interact with each other at the level of the operating system, that they are totally separate. They can't address each other's memory. They can't access each other's data at all unless you go ahead and configure it as such. And unless you go usually through the network, is that they can communicate with each other, through the network, right? Is where maybe this guy right here is hosting a file share. Maybe he's a file server. And maybe this guy right here is an application server that needs to access files on that file server, and maybe it does it through the network. And in this case, through the network, it might be in the same VLAN, so that network connectivity might never leave this physical machine here. That network traffic might go into our hypervisor and then just go straight over with our virtual networking that would be in the hypervisor. Now, the virtual networking in a hypervisor is not something we're going to cover in any detail at all here. That Cisco is very specific about this particular topic, that we're just talking about virtual machines and nothing vendor specific. I do list here VMware just as the ESXi hypervisor. That's just an example. There is, of course, solutions from Citrix, and then also, Hyper-V from Microsoft. And there are others as well that are open source and closed source. There are many options for hypervisors that you can do a little research and find one that would fit your needs appropriately. Now, Although this exam topic was only talking about virtual machines, I do want to go over a little bit more about what virtualization in the network looks like. So as far as network virtualization, some items, and I've seen this question come up on Cisco exams before, which is why I wanted to mention this, are some examples of network virtualization. Our virtual LAN, taking one physical switch and dicing it up into multiple virtual switches. Basically, that's essentially what's going on. It's not literally. There are other things that do this, like virtual device contexts on the Nexus and on the Cisco ASA. For our ASA contexts. But the virtual LAN is a type of virtualization. Our virtual SAN, having a VLAN for our storage area network, a virtual routing and forwarding instance, a virtual private network, being able to encrypt our data and send it across some overlay network and get to it as if we are on that same LAN and be on a virtual private network. Or virtual port channel. Virtual port channel is what allows multi-chassis Ether channel to work. We'll talk about that a little more later with Ether channel, and basically what that is, it allows you to bundle multiple links together. So you've got a switch over here and a switch over here, and you've got multiple links between each other, and it allows you to bundle them so that you get increased bandwidth. Now what virtual port channel does is it virtualizes this so that, say you've got, let's go ahead and erase this real quick. Say you've got a switch here, and a switch here, and a switch here. And then you've got two links going this way, and two links going this way. Is that this allows you to go ahead and bundle these so that these all look like one single link, one virtual link to a spanning tree, and give you multi-chassis Ether channel. But then, of course, as far as device virtualization goes, so that's really just network virtualization. As far as device virtualization goes, we just spent a little while talking about virtual machines, and that is in server hardware. Now, something I did want to mention briefly with virtual machines is that Cisco and other networking vendors do provide virtual machines of their appliances that work on generic hardware. You can get an ASA-V, which is a virtual ASA that runs on generic hardware. You don't need your physical ASA to be able to have ASA services and provide those services to your data center. You can spin this up in the cloud if you want, in your Azure or your Google Cloud, your AWS, and be able to have your services provided by an ASA in that kind of environment without having a physical appliance there. VSS is the virtual switching system. That's in our Nexus switches and allows you to take multiple Nexus switches and have them act as a single logical switch, have them basically share a brain, and have a single supervisor go ahead and control both of those switches. And we talked briefly about ASA device contexts. That ASA contexts allow you to take a single physical ASA, right? If you actually have your physical appliance, your physical ASA, and chop it up into multiple virtual ASAs so that each one actually acts as its own separate ASA, and you can allocate resources to each one so that no one context can take up all of the CPU utilization, can take up all of your clock cycles available in your device. So one of them could just be getting hammered by some attack and it won't affect the rest of your physical device. And then virtual device context on the Nexus switch line, that also allows for you to take your single Nexus switch and dice that up into virtual Nexus switches and actually create a full virtual machine, a full virtual Nexus switch that has its own ports assigned to it, its own hardware available to it to use. And it's very much like a virtual machine. but it is specific to a Nexus. And same thing with an ASA device context or an ASA context. It's very much like a virtual machine, but it's a little different though in the way Cisco handles that. Now, just like the other sections, let's go through a couple of practice questions before we finish off here. First, which of these are not a benefit of using virtual machines over physical machines? A, increased hardware utilization. And remember, this question, it said, which of these are not a benefit? Is it B, decreased administrative overhead, C, increased network bandwidth, or D, increased efficiency? A, we do get increased hardware utilization, so that's good. B, decreased administrative overhead. I didn't say this explicitly, but this is true. You have much easier management of your machines when you're able to manage your virtual machines as opposed to your physical machines, right? For your physical machines, you gotta either PowerShell into each of them or a remote desktop or physically walk over there and go manage it. With your virtual machines, you can usually connect to your host, or you might have a single orchestration or management software. In VMware, it might be like vCenter, where you go ahead and connect to your vCenter and you manage multiple VM hosts, which each have their own virtual machines in them, and be able to manage all of your machines from a single pane of glass and be able to do that quickly and easily. It does have decreased administrative overhead, and we did touch briefly on as well that the idea of spinning up a virtual machine as opposed to provisioning a new physical machine does have its own advantages. You can create templates, for your virtual machines and be able to automate a lot of that process, that there's a lot of administrative tasks that are reduced when you use virtualization instead of individual physical machines. So B, yes, is also a benefit. Now C, increased network bandwidth. This is only talking about virtual machines. It doesn't have any real bearing on our bandwidth available, so C is just not a benefit. And D, increased efficiency. Because of your decreased overhead, you end up getting increased efficiency, and your increased hardware utilization, that you get better efficiency out of your available resources. So the answer here would be C, that is not a benefit of using virtual machines. You're increasing network bandwidth. And then lastly, a virtual machine has direct access to the host machine hardware. True or false? This should be a pretty quick one just to make sure that you're paying attention. The answer is false. That although there are circumstances where you can provide your virtual machine access to your hardware, you can provide it direct access to that and pass through your hardware to your virtual machine. In general, and most generally, it does not have direct access to the host machine hardware, that it is using virtual hardware, and then the hypervisor is taking care of scheduling for that hardware and providing that to the guest operating system. Now, I hope that this has been informative for you, and I would like to thank you for viewing.